Okay, so now that we've spent some time graphing and talking just about what an exponential function is, we're now going to focus on finding the equation if you're given a graph. So we're sort of flipping the problem in this case. As a reminder, the general form for an exponential function is f of x equals a times b to the power of x. Keep in mind a is the y-intercept and b represents basically the growth rate or the rate of change. We'll talk more about that in a little bit. So let's just look at an example. Let's find the equation of the following graph. And I will say, I'm going to tell you right off the bat, this is an exponential equation, so you know what to look for. Let's say I have the point 0, 3, and then also the point 1, 4. And so here's my graph. You're given these 2 points, and you have to figure out A and B. In this case, A might be relatively straightforward to figure out because there is the y-intercept right there, so you know A has to be 3. If you ever forget that rule, something that will always work no matter what function you're looking at is to first set up some equations. So I know that f of 0 is 3, and I know that f of 1 is 4. So this tells me, so let's say you weren't sure about this, you'd forgotten that. This gives me 2 different equations. I have a times b to the power of 0 equals 3, and I have a times b to the power of 1 equals 4. Now the first equation can be rewritten because b to the power of 0, well, that's just 1. And so that tells me that a times 1 is 3. Well, that means that a equals 3. Now I plug this in, I substitute this into this equation, the second equation, and I get 3 times b to the power of 1. Well, b to the power of 1 is just b, has to equal 4. And solving for b in this case, dividing both sides by 3, I end up with 4/3 for b. So I'm actually done with the problem at this point. I know that the equation, based on my work over here on this side, will take all of this info. This tells me that the equation is f of x equals 3 times 4/3 to the power of x. And that's the answer. Please make sure when you're writing this that you include those parentheses. If you don't, then it just looks like this, 4/3 to the power of x, which looks to me like you're saying 4 to the x divided by 3, which is definitely not the same as 4 over 3 to the power of x. So please make sure that you're including the parentheses. All right, let's try another one. Let's say in this case we have the points, find the equation, the exponential equation of the graph going through the points 0, 2 and 2, 50. So in this case, I didn't actually show you the graph, but you could sketch it if you wanted. So 0, 2, and then 250. Part of the reason I didn't do this is because 50 is way off the charts. That's part of the reason I didn't give you the graph. And so the function looks something like that. So let's use the same strategy we used before. We actually already know A, but I'll go through in detail again. F of 0 is 2. F of 2 is 50. And so what this tells me, the first part, is that a times b to the power of 0 equals 2. Remember, b to the power of 0 is 1, so then I know that a equals 2. Now I'm going to plug that into this other one. So this tells me that a times b to the power of 2 is 50. But I know that a is 2. So 2 times b squared equals 50. Now this actually turns into kind of a polynomial. This is sort of a quadratic equation, but it's a little bit easier to solve because we can divide both sides by 2, and then I can just immediately see that b squared is 25. Taking the square root of both sides, I end up with b equals plus or minus 5. But keep in mind that we said b can't be negative, so that means that I have to have the plus 5 because b cannot be negative. So let's combine all of our work over there. I know that the function is f of x equals 2 times 5 to the power of x. And you could include parentheses here, but they're not necessary. I'll go ahead and put them on to hopefully reduce some confusion. But it's 2 times 5 to the x, and we're done. We figured out the equation based on the graph. So let's go ahead and end there. You can now do the two objectives outlined in the start. You can create a graph based on the equation, and you can also find the equation if you're given a graph.